Please kindly give me a thumbs up if you can hear me. Can you hear me now? Let me know if you can hear me. Yes, kindly let me know if you can hear me. Okay. Okay. Please, can you hear me now? Okay. Okay. Then kindly share this to your colleagues and let's. Some of you, I think I had to connect it and connect it backward. Okay. Okay. So let's patiently wait for your colleagues because I have to leave time for you to join. Okay. So over the course of the week, we started our topic, which you are saying we started with nuclear chemistry. So what we are trying to say, all the understanding is that we are going to what? The nucleus. So I'll be using my board here. So when we say the nucleus, as you can see my circle, we remember that we said that any atom, every atom has a central part around it. So this is our central part. So all that we are trying to do here is we want to study what is happening inside this nucleus. So this nucleus, what we are trying to look at here is that this nucleus, we go this, see? So now with this nucleus here, this tiny center here, we said that it contains what? So with this nucleus, what we are saying, please, is the sound okay now? Can you hear me? The sound is not clear. Okay. I think it's because of the network. Those of you who can hear me, give me a thumbs up, and those of you who can't, just say no for me. It's okay. Okay. It's not stable. Yes. So this is what we are going to try to do. I would save the video for you in order not to disturb you. I think at this time of the day, the network is not stable. Yes, I get you. Also, the picture quality is a problem. Now, okay. Can you see the board at my back? Before I continue, can you see the board? Give me a thumbs up if you can see my board. Okay. So now, thank you. Okay. All those of you who are saying the sound is a problem, please, I'm going to save this video for you on my channel so that you get a time to watch it very well. Now, I just don't want to take very few much of your time. So quickly, we are going to use the board and kindly observe what we are trying to do. Now, I gave you an assignment for you to do for me, and that was exercise 2. Now, with the exercise 2, most of you had a challenge with it. So quickly, that when you encounter a problem like that, so that when you encounter a problem like that, you know how to solve it. So quickly, let's look at exercise 2. So the first question was question 1. With question 1, most of you couldn't solve it. I don't know why. Though we did a trial one. Yes, I went through, but most of you couldn't solve it. Though I just wanted you to just apply what we've done. So quickly, let's look at exercise 2. I'm reposting back exercise 2 into the group. So this is what we are discussing, exercise 2. Now, with exercise 2, this was the exercise that I gave you. And most of you were having challenges with it. I've posted it back to the group, which I expect that by now, most of you have it. So now, let's look at it. So the first question that I wanted you, or I gave it to you is, now, you were given what we called thorium 22290. And I asked you, how many alpha particles or how many beta particles were being emitted? Can you see the board? So now, if thorium 222 disintegrate, if thorium now changes to 208 Pb lead, how many alpha particles or how many beta particles? How many alpha particles or how many beta particles will be emitted? So now, okay, please, a minute. I think the writings are turning upside down. So let me do something and get back to you. Hey Charlie, and your content creator for some bro. And how will I see? Oh Charlie. Is it okay now? Is it okay now? Okay. So now, so I gave you this. The first question was, how many alpha particles and how many beta particles were being what? Emitted. So here, you don't know the number of alpha particles or beta particles that are being emitted. So this is what you are going to do. You are going to say, let X represent the alpha particles, then you let Y represent the beta particles. So since you don't know the number, you represent the alpha particles and beta particles by X and Y. So here, this is how you are going to. So thorium 22290 has emitted X alpha particles plus Y beta particles given as 20882 PB. So this should be your expression. So what you are saying is thorium 232. Okay. So now you are saying that thorium here is 232. So you represent this by X and Y. So you have to find, if you want to find the number of alpha particles and beta particles, just represent it by F and Y and solve for X and again solve for Y. So how do we do that? You will now substitute the mass number and atomic number of thorium. So this is X. Remember, I've told you that alpha particle has a mass number of 4, atomic number of 2, plus beta particle has a mass number of 0, an atomic number of -1, plus 20882 PB. So how do you solve it? Observing what? The law of conservation of mass number. What we are saying is that 232 will be equal to, here, X times 4 plus Y times 0 plus 208, which is the mass number. So this is what you have to do. Just represent the number of alpha particles by X and the number of beta particles by Y. Then you solve for X and Y. So here, we are going to get 232 is equal to X times 4 here will give us 4X. Y times 0 will be what? 0 plus 208. So here, make X the subject. So this one will come here. So 332 minus 208 equal to 4X. So when you subtract 232 from what? 208, what are we going to get? So here, when we do the subtraction, we are going to get what? 12, right? So here, 232, 8, 12, 4. And now this is 24 is equal to 4X. So if you want X, you divide here on 4, here on 4. This cancels this. So X will be equal to what? 6. So this was a simple question trying to what? Help you understand. This was trying to help you understand how to get X and Y. So now with this, you are seeing that our X here is 1, our X here is 6. Yes, any question? Please, can you hear me? Yes, can you hear me? So now, who has a problem with how I arrived at the 6? Is there any problem? So here, what I want you to know is that when you are told to find what of Y, so what of Y, if we are now coming to solve for Y, but I hope now you've seen how I arrived at my X. So now, the X here means that the particle is going to emit 6 alpha particles. Yes, question like this, it is very compulsory for you to show working. Remember that you must tell us how you arrived at your problem. So please, always show working. And I've told you that in chemistry, the marks awarded to a question should guide you how to solve them. So if the marks awarded to this question is 2 marks or is 1 mark, you should know that we are only interested in the answer. But if the question is awarding 5 marks, 4 marks, then if you don't show working, you are going to what? Be penalized. You are going to miss a lot of marks. And I think that was one of the main reasons most of you couldn't perform in your chemistry exams, because most of you were jumping steps. Most of you, because when you look at the marks allocated to a question, you should be able, or you must be willing to look at how to come out with a solution. So please, you solving the question is very important and you must understand. Okay, so this is how we solve for X. Are we good? Now, quickly, let's look at how to solve for Y. In that same scenario, let's go back to the board and look at how we are going to solve for Y. So as you can see, how did I solve for Y? So I've equated, I have equated the atomic numbers. So now, as you can see here, what are we having? When you equate the atomic number, remember that the X is affecting the alpha particles. So when the X affects the alpha particles, what are we going to see? We are going to see that 90 is equal to X times 2 plus Y times minus 1 plus what? 82. So when you do your calculation, you are going to get what? 90 is equal to 2x minus y plus 82. Now, with this, remember that we have already calculated for x. And what did we get for x when we calculated for x? We had x to be what? To be 20, or x to be 6. So when you substitute x inside the equation, you are going to get 12 plus 82 minus y. So you make y the subject. So what we are trying to let you know is that whenever you are given a question like this is how to solve it. So when you make y the subject, you are going to get y to be, say, 4. So y here is going to be 4. So I saw some of you using activity series. You can't be specific. And that approach would not help you arrive this answer. No. So whenever you have a question like this is the correct approach to use to solve the question. Are we okay? Yes, please, any question? So this is what I expect you to solve the question. This is a simple way I want you to use to solve the question. So here, the number of alpha particles that was emitted were what? Was 6. And the number of beta particles was 4. So now with this idea, you can solve the question 4. It's a likely question. This same approach is what you are going to use. Yes, any question? Okay, yes. Justice Kwa, please, what don't you understand? Yes, you are going to do the correction. So this is how you are going to solve the question for question 1. So this was the question that most of you were complaining that they couldn't solve. And this is how we solve the question. Any question? Because I think the network is, I have to find solution. So any question? Any question? So now, use this approach. Use this approach. Okay. So now let's look at question 4. Let's look at question 4. Exercise 4. We are coming to use the same approach to solve for what? Exercise 4. So the question was, how many alpha particles and beta particles will be emitted in changing from what? A218 to B206. So we are solving question 4. So now, so this is question 4. Okay. So quickly, yes, kindly solve for this for me. Kindly try this question for me. Let's try it. Let's try it. Now, this is question 4. Try this for me and let's see. Okay. So now, x is 3. Okay. What about y? Now, please, if you have a, please kindly try this for me. Someone is saying x is 3, y is 4. Okay. Now, you see that the question 4 follows the same question as question 1. And now you are being told to calculate how many alpha particles and how many beta particles are being what? Emitted. So you don't know the number of alpha particles and you also don't know the number of beta particles. So you represent these by what? Variable. So you let x represent the number of alpha particles and y represent the number of what? Beta particles. So here, this is what you are going to get. So you substitute in your mass number and atomic number 4, 2, 0, minus 1. So here, so with this, you can see that we've had x, which is representing the number of alpha particles, to be 3. And you have done a very good job. Excellent. Excellent. So now I can see when you get a question like this, you'll be able to solve it. So quickly. Now, those of you who had challenge with question 1 and question 4, I expect you to do them. In fact, I expect you to do them. Okay. So this is how we solve the question. Okay. Any question? Any question? Yes. Solomon Safo, any question? Let me see. Any question? Okay. Mostly, someone is asking, can I give a question concerning gamma radiation? Mostly gamma radiation, the mass number and atomic number is 0. So when you calculate for them, you are definitely going to get 0, 0 for it. So I'm going to send you a new set of questions. Solve it for me because mostly the question 2 that I gave most of you, you couldn't solve it. And I don't know why. Because like I've been telling you, most of the time you must what? Apply. Apply the knowledge. So please, God willing, I'm going to send you a new set of questions that is going to replace the question 2. Your performance was very, very low when I went through, But now that you know how to solve it, you would be able to attack. Today being our first time, I don't want to take much of our time. So please, I'm going to work on the network issue together with the sound. So please, kindly forgive me for today. However, I would leave the video here so that you take your time and you go through them. Thank you.